to go ahead and add and subtract radicals. Now, if you remember, back in the days, just last week when we were doing like terms, if we had 2x plus 3x, I could go ahead and put those together because they were alike and I would get 5x. But if I had something like 2x plus 3y, they were not alike. And because they were not alike, I could not put them together. And so this was my simplified answer. Hope we remember. Radicals will work in a similar fashion. If you are adding or subtracting radicals, why are you having a conversation? Don't let my online fans get all upset. Okay. So, oh my God. You're messing with my likes and my views. When y'all watching the video, y'all know the spots. Y'all know why the spots is here. I'm sorry. As I was saying, I cannot add or subtract unless they are like terms. So if I look here and I look here, I realize that the radicals are the same. It is the square root of 2 and it's the square root of 2. Because they are alike, it gives me the right to add the 3 and the 4. As such, my answer is 7 radical 2. I always want to also check if I can simplify that. And I know I can't simplify radical 2, so I am done. Let's look at number 2. For number 2, ooh la la. If I look at it, I also recognize that these are like radicals. Because they are alike, I can go ahead and subtract. 3 minus 5 is negative 2, and then I have the square root of 5. And then I know that 5 cannot be simplified, it's just 5 and 1, so I am done. Let's look at something like number 4. If I look at number 4, I know I'm going to add them, so I'm going to check if they're alike. One is the square root of 2, and the other is the square root of 8. I realized, I can't just add them because they are not alike. Because they're not alike, maybe I'm done, maybe I'm not. Let me see if there's something that can be simplified. I know the square root of 2 cannot be simplified, but let me check the square root of 8. Factors of 8 are 4 and 2, 8 and 1, and lo and behold, this is a perfect square. So the square root of 8 can indeed be simplified. I'm going to simplify it. It breaks into the square root of 4 and the square root of 2. Well, the square root of 4 we know by now is 2. So we have 3 times 2. 3 times 2, and then we have the square root of 2. So all of this can be simplified into 6 radical 2. And then, of course, I couldn't do anything with the first one, so I still have my 6 radical 2. You can carry it down all the time, but I just carried it down at the end. So now, do they have like terms? Yes, they're both square root of 2, and 6 plus 6 is 12, so this is 12 radical 2. I'm done. Let's look at number 15. For number 15, ooh la la, they are not like radicals, so I can't add or subtract them yet. But again, they can be simplified. For 8, I just did it, so I know that 8 can be broken into the square root of 4, and the square root of 2. So that this becomes 15 times 2 times the square root of 2. That leaves us with 30 radical 2. Now let's approach the 12. Well, factors of 12, 12 and 1, 6 and 2, 3 and 4. Okay. Any of these a perfect square? No, no, yeah, there goes that 4. So this can be broken into 3, square root of 4, and the square root of 3. Well, the square root of 4 again is a number. The square root of 4 is 2, so it's 3 times 2 times the square root of 3. That means it's 6 times the square root of 3. Now, I still look. This is a square root of 2, and this is a square root of 3. Are they like terms? No, because they are not like terms. I can't go subtracting the 30 and the 6. Therefore, I am actually done. Everything was simplified. I am good to go. Thank you. Okay. I'm going to go ahead and do these two with you as well. Keep in mind, at any moment you want to pause and try some on your own, please go ahead and pause and try some on your own. That would be awesome. Let's look at number 8. This one is fancy-ish. Cubed roots are going to work again the same way. So we have 6 cubed root of 8 plus 2 cubed root of 4. They are not like cubes. So I can't just add the two things and get 8 cubed root of something. I have to simplify them. Well, hopefully by now we recognize that the cubed root of 8 is a number. The cubed root of 8 is 2. And so this side can simplify to 12. And then I look here, the cubed root of 4 can't be broken down, can't be broken down. So then I am still just left with 2 cubed root of 4. Now you might say, can I add those together and get 14 cubed root of 4? No, because they are not like terms. This is a whole number and this is a number with a cube. So simplify them here. It would be like saying 12 plus 2x. We don't get 14x. So I cannot add those two. Go ahead and take the time to try the other problems. 3, 6, 7, 9, 10, and 11. Go ahead and try them. Pause and try them. All right, so for number 3, these match. So 9 minus 2 is 7. You should have had 7 radical 3. On number 6, I have 7 radical 10, and then I have 3 square root of 40. This is already simplified, but the 40 is not. 40 can be broken into the square root of 4 and the square root of 10. So then we have 7 square root of 10 plus 3 times 2 square root of 10. 7 square root of 10 plus 6 square root of 10, which will give me 13 square root of 10. When we come down here, we see that these are the same. So I can go ahead and add them, and I would have gotten 15 cubed root of 3. Ooh. Oh, Right. Then on number 9, we have 2 cubed root of 270 minus 3 cubed root of 10. I know this can't be simplified, but maybe this portion can, and it indeed can. It can be broken into 2 cubed root of 27 and the cubed root of 10 minus 3 cubed root of 10. And so the cubed root of 27 is a number. It's 3. We have 2 times 3 times the cubed root of 10 minus 3 times the cubed root of 10. Well, 2 times 3 is 6. Oh, no.